Welcome, fellow explorers of the cosmos. Today, we're diving into the Bloch Sphere, a concept fundamental to quantum mechanics and quantum computing. This sphere is a powerful tool that helps us visualize and understand the bizarre behavior of qubits, the building blocks of quantum computers. So get ready to have your minds blown wide open because things are about to get quantumly awesome. Imagine a sphere, but not just any sphere. Picture a perfectly smooth, glowing sphere floating in a vast, dark space. This sphere is not just a simple geometric shape. It holds the key to understanding the fundamental unit of quantum information. This is the Bloch Sphere, a visual representation of a single qubit, the fundamental unit of information in quantum computing. The Bloch Sphere helps us visualize the complex and often counterintuitive nature of qubits. Unlike classical bits, which can be either 0 or 1, a qubit can exist in a superposition, being both 0 and 1 simultaneously. This superposition is what gives quantum computing its incredible power and potential. Think of it like a spinning coin. Before it settles, it's both heads and tails. This analogy helps us grasp the idea of superposition, where a qubit can be in multiple states at once. At the north pole of our sphere, we have the state 0, representing 0. This is one of the two basis states of a qubit. At the south pole, we have 1 representing 1. Together with the North Pole, these 2 points define the classical states of a qubit. A qubit can be anywhere on the surface of the sphere, representing a superposition of these two states. This surface is where the magic of quantum mechanics happens. These coordinates are determined by two angles, theta, theta, and phi, phi. These angles help us pinpoint the exact state of our qubit on the Bloch sphere. Theta tells us how far we are from the North Pole, determining the probability of our qubit collapsing to a 0 or a 1 when measured. The closer to the North Pole, the higher the chance of measuring a 0. Phi gives us the qubit's phase, a crucial factor determining how our qubit interacts with others. The phase is essential for understanding quantum interference and entanglement. When we measure a qubit, we force it to collapse into either a 0 or a 1 based on its position on the Bloch sphere. This collapse is a fundamental aspect of quantum measurement. The closer our qubit is to the North Pole, the higher the probability of it collapsing to a 0, and vice versa for the South Pole. This probabilistic nature is what makes quantum computing so different from classical computing. The Bloch sphere allows us to visualize and understand the state of our qubit, giving us a handle on the strangeness of the quantum world. It serves as a bridge between the abstract mathematics of quantum mechanics and our intuitive understanding. It's like having a map to navigate the uncharted territory of quantum mechanics. With the Bloch sphere, we can explore and make sense of the bizarre and fascinating world of qubits and quantum states. Hold on to your hats, folks. We're about to dive into the mesmerizing world of quantum computing, where qubits dance on the Bloch sphere. Now that we've explored the structure of the Bloch sphere, let's delve deeper into its significance and how it serves as a stage for our qubits. The Bloch sphere is a powerful visualization tool that helps us understand the state of a qubit. Imagine it as a globe where each point represents a possible state of our qubit. Quantum gates are like the instructions in our quantum computer program. They are the operations that allow us to manipulate the state of qubits, guiding them through their quantum journey. These gates are mathematical operations that act on our qubits, changing their state on the Bloch sphere. Each gate has a unique function and purpose in the quantum computation process. One of the most famous quantum gates is the Hadamard gate. This gate takes our qubit from a definite state and puts it into a superposition where it can be both 0 and 1 simultaneously. The X gate, also known as the NOT gate, flips our qubit from the North Pole to the South Pole and vice versa. This means it switches a 0 to a 1 and a 1 to a 0, effectively inverting the qubit's state. The Z gate and the phase gate are crucial for manipulating the qubit's phase. These gates are essential for creating interference patterns, which are a cornerstone of quantum computations. These quantum gates are the building blocks of quantum algorithms. By combining them in various sequences, we can create complex operations that allow quantum computers to tackle problems that are currently unsolvable by classical computers. By strategically applying these gates, we can choreograph the dance of our qubits on the Bloch sphere. Each gate adds a new step to the dance, guiding the qubits through a series of transformations. It's like conducting an orchestra of quantum particles, guiding them to create a harmonious melody of computation. Each qubit plays its part, contributing to the overall performance. This intricate dance of qubits can revolutionize fields like medicine, materials science, and artificial intelligence. Imagine developing new drugs, creating advanced materials, or designing intelligent systems with unprecedented efficiency. So buckle up, because with the power of quantum gates, we're about to witness a quantum revolution. The future is bright, and the possibilities are endless. It's like conducting an orchestra of quantum particles, guiding them to create a harmonious melody of computation that can revolutionize fields like medicine, materials science, and artificial intelligence. The dance of qubits on the Bloch sphere is just the beginning of this exciting journey. Fasten your seatbelts, quantum adventurers. We're about to take the Bloch sphere for a spin and see it in action. Quantum algorithms harness the power of superposition and entanglement to solve problems that would take classical computers billions of years. The Bloch sphere helps us visualize how these algorithms work their magic. Take Shor's algorithm, for example, which can factor large numbers exponentially faster than any known classical algorithm. The Bloch sphere helps us visualize how Shor's algorithm manipulates qubits. Quantum key distribution, QKD protocols rely on the principles of quantum mechanics to generate and distribute secret keys. The Bloch sphere helps us visualize and understand the quantum states of the photons used in these protocols. It also plays a vital role in quantum error correction, protecting fragile quantum information from noise and errors. By representing qubits on the Bloch sphere, we can visualize and develop error correction codes. The Bloch sphere also finds applications in quantum simulations, where we use quantum computers to simulate the behavior of complex systems. By representing the quantum states of these systems on the Bloch sphere, we can gain insights into their properties and behavior. The Bloch sphere is a workhorse in the quantum world, driving innovation and pushing the boundaries of what's possible. As we reach the end of our quantum journey, it's time to reflect on the profound importance of the Bloch sphere. This seemingly simple geometric representation has become a cornerstone in the field of quantum mechanics, providing a bridge between abstract theory and tangible understanding. It's more than just a visual aid, it's a fundamental tool that has revolutionized our understanding of quantum mechanics. The Bloch sphere allows scientists and researchers to visualize the state of a qubit, which is the basic unit of quantum information, in a way that is both intuitive and insightful. The Bloch sphere is like a quantum Rosetta stone, allowing us to decipher the language of the quantum world. It translates the complex and often counterintuitive principles of quantum mechanics into a form that can be more easily understood and manipulated. Its ability to visually represent the state of a qubit has been instrumental in developing and understanding quantum algorithms. By mapping the qubit's state onto the surface of the Bloch sphere, researchers can see how different operations affect the qubit, leading to deeper insights and more effective algorithms. The Bloch sphere gives us a tangible, visual representation of this abstract concept. It allows us to see the qubit state as a point on a sphere, where different points correspond to different quantum states. This visualization is crucial for both teaching and research, making complex ideas more accessible. It's a fundamental tool for quantum control, allowing us to manipulate qubits with precision and accuracy using quantum gates. These gates, which are the building blocks of quantum circuits, can be represented as rotations on the Bloch sphere, providing a clear and intuitive way to understand their effects. These gates, represented as rotations on the Bloch sphere, are the building blocks of quantum circuits. By visualizing these rotations, we can design and implement complex quantum algorithms that harness the full power of quantum computing. By understanding how these gates affect the qubit state on the Bloch sphere, we can design and implement complex quantum algorithms. This understanding is essential for advancing the field of quantum computing and developing new technologies that can solve problems beyond the reach of classical computers. The Bloch sphere has also been instrumental in the development of quantum error correction techniques. These techniques are crucial for maintaining the integrity of quantum information in the presence of noise and other errors that can occur in a quantum system. By representing qubits on the Bloch sphere, we can visualize and understand the effects of noise and decoherence. This visualization helps researchers develop strategies to mitigate these effects, ensuring that quantum computations remain accurate and reliable. This understanding has led to the development of ingenious error correction codes. These codes are designed to detect and correct errors in quantum information, making it possible to perform long and complex quantum computations without losing information. The Bloch Sphere is a testament to the power of human ingenuity in unraveling the mysteries of the universe. It has transformed our understanding of quantum mechanics and opened up new possibilities for technology and discovery. As we continue to explore the quantum realm, the Bloch Sphere will remain an essential tool, guiding us toward new horizons. Thanks for joining me on this exhilarating journey into the heart of the quantum realm. We've explored the fascinating world of the Bloch Sphere. Remember, the Bloch Sphere is just one piece of the quantum puzzle. There's a whole universe of fascinating concepts waiting to be explored. If you're eager to delve deeper, don't forget to like this video, share it with your fellow quantum enthusiasts, and subscribe to the channel for more mind-bending explorations. Until next time, keep exploring the universe from the vast cosmos to the enigmatic quantum realm.